Welcome to this webinar presented by the IET's Anglian Coastal Local Network, which represents members in Norfolk and Suffolk. Welcome also to folks from other parts of the UK and indeed globally. I'm delighted to welcome you all. I'm Kevin Foster. I chair the Anglian Coastal Local Network, and I will be your host for this evening. I'm delighted to introduce our speaker, Somdip Day. Somdip is an embedded artificial intelligence scientist affiliated to the University of Essex and to the Samsung R&D Institute. He is also a technology contributor to She Finds Media. He is a serial entrepreneur with focus on social entrepreneurship and serves as the technical committee member of several top computing conferences such as IEEE EdgeCom, IEEE CS Cloud, IEEE Computing in Science and Engineering, and a number of others, as well as editing several technical publications. His current research focuses on energy efficiency, performance, and reliability of computer vision applications on heterogeneous multiprocessor system on chips. So Somdip, over to you.
Thank you so much, Kevin. Really appreciate the kind introduction. Welcome, everyone. Good afternoon and good evening, wherever you are located at the moment. And thank you for coming to this talk and enabling me to share my work on how we are using machine learning to make smartphones even smarter in terms of prolonging battery and its performance. So let's jump into it. Before we go into the content of the talk itself, I want you to give a scenario. Imagine you had a long day at work and you're coming back home, either using a public transport or you're using your own car to get back home. And you suddenly notice that your smartphone has less than 20% battery. However, you have a long way to get back home and you plug in your phone to your car, or you desperately find a charging hub anywhere on the public transport to go through your journey itself, because smartphones are not just a tool to call other people, but at the same time plays an integral part of your life itself. So instead of getting bored, you might have ended up spending more time on the smartphone itself. So having adequate charge is very important for you. Now, if you can relate to this scenario, I would like you or urge you to answer to this poll where you can choose yes or no to say that whether you have been in this scenario at some point in your life. So we'll give around 30 seconds for you to answer this poll question and would really appreciate how you feel.
%100% answered.
Great, right? So most of us, well, technically all of us in general do go through such an issue. And that's where the talk itself is revolved around. So getting on with the talk itself, we are first going to briefly talk about the advancement and the recent state of artificial intelligence and machine learning. Then we are going to move on to understand what are the current power and thermal management schemes that are available in smartphones. After that, I'm going to introduce our work, which we call the Next. And that enables the smartphone to prolong their battery life than what it does today. And at the end, we will be talking about some of the future work that we are currently working on and we tend to release in coming future, and finally conclude the talk itself. So without further ado, let's get on with it. Now, artificial intelligence and machine learning is a topic most of us have heard. It's If it's used by a company, it might be a buzzword to many of us, but at the same time, without even realizing, intelligence and machine learning is somehow related to most industries or used in most industries in some form or the other. So let's briefly recap. What are these fields? Artificial intelligence, or in short, if we call it AI, is the field of study to enable computing machines to perform tasks that are commonly associated with intelligent beings like us humans. On the other hand, machine learning, or ML in short, is the subfield of artificial intelligence where the computing machine can improve automatically through its experience and by the use of data. Now, traditionally, machine learning can be broadly categorized into three categories: supervised learning, unsupervised learning, and reinforcement machine learning. Now, when it comes to supervised learning, the computing machine learns patterns from labeled data and then ends up predicting in some form or other. Whereas when it comes to unsupervised learning, the computing machine actually learns the pattern from unlabeled data and then predicts in some form or the other. And on the other hand, we have reinforcement learning, which can be thought as a computing agent or an intelligent agent which understands its environment by taking actions and then optimizes the action based on the reward it gets from the environment itself. Now, we will be discussing more about reinforcement learning shortly, but again, I wanted to briefly mention about the different types of traditional machine learning algorithms that are available today. That being said, recently in the current years, we can also see rise of other forms of machine learning algorithm. For example, semi-supervised learning, where the algorithm or the computing machine learns partly from labeled data and then tries to learn pattern from unlabeled data so that it can do some form of prediction with some form of confidence. Now, for this talk, two types of or two forms of machine learning algorithm is very important. So they are embedded machine learning and reinforcement learning itself. Now, most of us have heard about machine learning, but not a lot of people are aware of embedded machine learning, or EML, or embedded ML in short. Embedded machine learning is the subfield of machine learning where the machine learning model is run on the embedded system with limited computing resources. And such devices could be wearables or edge devices like your smartphones, and also microcontrollers. So it enables running the machine learning algorithm on such limited resource devices. Now, you might be asking, what is the benefit of having embedded machine learning or developing the field of embedded machine learning? When it comes to AI and machine learning, one of the biggest concern among the end user or consumer is the privacy and security of their data, especially because machine learning is very much dependent on data to learn about pattern and then predict based on that. So, for example, in healthcare system, if you want to employ machine learning to understand or diagnose cancer. In that way, you do not want your own data to be shared with some institution whom you cannot trust. So in this sense, embedded machine learning has the advantage because the machine learning model can train or learn on the user's device and then infer or predict based on the learning that it achieved from the user's data on the user's device. So privacy and security of data in such scenario is completely preserved. Now, as I have briefly mentioned about reinforcement learning, let's look like more in-depth view on what such an algorithm or type of system is. Reinforcement learning is a type of machine learning algorithm where an intelligent agent, which is a computing system itself, that perceives its environment to take actions autonomously in order to achieve cumulative rewards based on the knowledge gathered from the environment. So let's look at the block diagram, representative block diagram here on the right-hand side. So this can be thought as a representation of reinforcement learning agent, where in simple terms, we can say that the reinforcement learning agent sits in a computing system and it learns from its environment, which is basically this computing system itself. And the way it learns from it is by taking actions. And based on the action, it achieves some form of reward. Now, the goal of such an intelligent agent is to optimize the action it takes in that environment such that it can optimize the reward it gets as well. So that's how a reinforcement learning agent works in a computing environment itself. Now, the main talk of the smartphone, which the whole talk is revolved around. As we all know, smartphones have become an integral part of our lives. We use it not just for our personal reason, but professional as well as general lifestyle and health as well. We use it to call our beloved ones and our friends, but at the same time, we can monitor our health and as well entertain us in many different forms. Now, let me share some statistics which will be very useful going forward with the talk. In 2020, there were 3.5 billion smartphone users in the world. Among all the personal devices that are available today, which is smartphone, tablets, laptops, personal computer, smartphone actually has one of the highest adoption rate, especially in countries like developing countries, like in East of Asia or in Asia, like India, China, Bangladesh. They have a high adoption rate of smartphones, especially because such devices are far more affordable compared to other type of personal devices till date. In 2019, 56% of all web traffic worldwide originated through smartphones or mobile devices itself. According to the company eMarketer, which collects statistical data on different topics, in 2018, mobile users spent almost 4 hours, 16 minutes on an average on their smartphone to like get entertained through in-apps or through mobile web. Now, these are some more statistics. So the statistics published by eMarketer shows an increase of 15.32% in time spent on in-apps and mobile web by mobile users in last 5 years. According to another company, statistics company, which is MediaKicks, an average of 1 hour 56 minutes, which is equivalent to almost 2 hours, was spent on top 5 social media platforms, including YouTube, Facebook, Snapchat, Instagram, and Twitter. So from here, you can notice how much time we end up spending on smartphone and using the apps on them. According to Rescue Time, an average person picks up or look at their phones almost 52 times during their workday. Now, out of these sessions, almost 70% of these sessions are less than 2 minutes. 25% of the session lasts somewhere between 2 to 10 minutes with a medium of around 5 minutes, and 5% of the sessions prolonged over 10 minutes itself. So even the duration of the user picking up or looking at their edge device, which is a smartphone, every time varies from user to user, and hence it makes it like the session more stochastic in nature. So if a human being has to go around and predict based on the user's interaction that how the user is using their smartphone, it will be almost impossible, because this each and every session are dependent on the user themselves and they are stochastic. So why do we need to understand these statistics? Because in order to optimize the battery performance and performance of the app of such smartphone, we need a method which is capable of learning the pattern of individual user. So in conclusion, mobile phone users are increasing in number, and interaction session varies inter-session as well as from the user to user. Now, interestingly, the current standard of smartphone is that most smartphone that you can think of or you will be using or you are using come equipped with heterogeneous multiprocessor system on chips, or MPSOC in short. So if you're using Samsung devices or Huawei or iPhone or Google or any phone that is a smartphone today, uses the chip which itself hosts heterogeneous multiprocessor system on chip. Now, what is that? In a heterogeneous multiprocessor system on chip, it hosts different types of processing element or processor to perform different type of tasks. This diagram in front of you is a representative of how a modern multiprocessor system on chip look like. So it has different types of CPU, such as big CPUs and little CPUs, and also you have GPUs to perform different tasks. Now, why would we have big CPUs and little CPUs? Now, the core ideology behind it is that big CPUs are actually very compute intensive in nature, so they can perform compute intensive tasks in a short amount of time. But the disadvantage of such processor on a mobile system is that they end up consuming a lot of power. Whereas you have little CPUs, or like we call them the little processors, they in general are far more power efficient, but are not capable of performing compute intensive tasks. Now, the reason to have these different type of CPUs on a smartphone is being that it is capable of catering for different performance requirement and also managing the power of such smartphone devices. And you also have GPUs to perform more media related tasks, or nowadays processors like a multiprocessor system on chip or MPSOC also come equipped with NPUs, which is neural processing unit, which are dedicated processor to train and infer machine learning model on such devices. So this is the concept of heterogeneous multiprocessor on chip in general, which are powering majority of the smartphone that we are we have access today. Now that we have explored the chip or the hardware side of smartphone devices, let's look at some of the most popular power and thermal management mechanisms that are used in smartphones today. One of the popular mechanism is called dynamic power management, which actually allows idle processing element or processes or idle components of the system to be suspended if required in order to reduce energy consumption. Another popular mechanism, which is devised by numerous researchers and engineers in the field, is dynamic voltage frequency scaling, or DVFS in short, which allows processors to operate at variable voltage frequency levels so that a harmony between performance and power consumption could be achieved. Other popular power and thermal management mechanisms include customization of processors to match the processing needed of a task on a multi-processor system on chip. Or it can also include customization of cache-based memory access, because accessing cache in processor, different levels of cache memory in processor could consume a lot of power as well. So customizing such cache-based memory could also help in reducing power and thermal behavior of such devices. And we also have mapping task of an application to the processor so that workload could be balanced across all the processor in the MPSoC, such that it improves the utilization of the processor effectively and reduces the energy consumption. Now, in modern smartphones, either of any of these methods could be used, or a set of combination of these methods are actually utilized in order to optimize the power and thermal behavior of such smartphones. Now, the important power and thermal management scheme that we are going to focus today is dynamic voltage frequency scaling, because we in our methodology utilize that as it's one of the most popular mechanism to save power, to reduce power consumption, and also improve the performance at the same time. So DVFS, or dynamic voltage frequency scaling, is actually used to reduce the dynamic power consumption of the MPSoC. And the dynamic power consumption can be represented in this mathematical formula, where P, which is the dynamic power consumption, is proportional to V square F, where V is the voltage of the processor, and the F is the operating frequency of the processor. So the voltage and frequency, they come as a pair, and modern processors are capable of running a different voltage frequency pair itself. Now, interestingly, when the processor run at different frequency, based on the frequency, the execution time also changes. Execution time of the running application also changes accordingly. So in front of us, we have a representative graph, which shows that as the operating frequency of the processor scales, the execution time also varies accordingly. So if the operating frequency is high or higher, then the execution time is less. Whereas if the operating frequency is less, then the execution time is higher. Now, the sweet spot when it comes to dynamic voltage frequency scaling in MPSOC or in smartphones, the sweet spot is somewhere in the middle, because in that way you can ensure that the execution time of the application is desirable enough so that it can cater for the performance requirement of the application. But at the same time, because the operating frequency is somewhere in the middle, it's more power efficient than if the application would have been to run on a higher frequency of the processor. That's why this mechanism is so desirable among the researcher and engineer in this field of research. Now, before I introduce the method next that we have developed as part of like making smartphone smarter in terms of performance optimization and battery optimization, I want to point out a couple of observations that we have noticed as part of using smartphones. Now, the first observation is that the user, when it comes to smartphone, the user interacts mostly with the touchscreen of the smartphone device. So all smartphone today come with a touchscreen that enables the user to interact with the device. Now, if you're using Android or you're using iOS, regardless, the task processing when it comes to smartphone is very similar. So as you can see here in the diagram, the user interacts with the display of the smartphone. Then depending on which part of the display you have interacted with or you have touched, that triggers an action or a function on the application that the user is interacting with. Now, depending on which function is triggered, the application makes some computation, and then the application returns the updated data to the view or the display itself. And finally, the display is updated based on that, and the user finally gets the output as well. So everything, when you perform a set of action on smartphone, is dependent on how the user is interacting with the smartphone's touchscreen itself. So this is a very important observation, which before this work hasn't been explored that much. I know it's simple and intuitive to most of us, but back in 2020, not a lot of us have actually thought about this when it comes to power and thermal optimization in smartphone. Now, the second observation that we notice as part of this research project is that we chose Samsung Galaxy Note 9 smartphone, which is utilizing Exynos 9810 MPSOC. So we observe the behavior of different application on such a smartphone to see the correlation between frames per second of FPS and the operating frequency of the processor. Now, why do I introduce frames per second? So when you are interacting with the smartphone's touchscreen, everything is represented as FPS itself. That's why it's important for us to observe the relationship between the FPS and the operating frequency of the processor itself. So what we did, we ran the device for almost 5 minutes, and we used different type of application to see the difference in the FPS when correlated to the operating frequency. So in that 5-minute session, we though ran several 5-minute sessions, but one of the session that we have run is that first we just kept the smartphone on the home screen. So we did nothing, and we observe the change in operating frequency of the processor. And then we switch to Facebook app to see how the FPS changes along with the operating frequency. After Facebook, we switched to Spotify music streaming app, where we try to observe again the relationship between FPS and the operating frequency of the processor of such system. So on the right hand side, you can see that we have a representative diagram of how FPS and operating frequency are correlated in some form. So on the x-axis, you have the execution time, which is the like 5-minute time period session. On the primary axis, you can see the FPS or frames per second. And on the secondary axis, you have the operating frequency of the big CPUs of the MPSoC of Samsung Note 9 device. Now, one thing you can notice, right? So here you can see in the, when we were executing or when we are on the home screen of the Android smartphone, you can see the operating frequency kind of like jumps all around in different way. And here, the black line represent the operating frequency of the big CPUs, whereas the blue line represents the operating frequency of the little CPUs. So you can see they kind of changes a lot. But in comparison, you can say that the FPS kind of changes at certain point and just stays the same at another point. Same can be said for Facebook application and Spotify as well. Especially on Spotify, it is very evident that although the operating frequency has been changing a lot, especially running at very high frequencies, but at the same time, the FPS or the frames per second generated while using Spotify streaming, like a music streaming application, is low, like it completely plateaus to 0. So from this, we can observe that higher operating frequency does not always generate higher FPS. So if you can recall, the two observations that we have just noticed are very important, or they kind of forms the foundation of our research project itself. Now, in order to enable our device some form of algorithm that learns how the user is interacting with the smartphone, so that the algorithm can choose a desirable operating frequency such that it can reduce the power consumption while maintaining the same performance requirement of the application, we chose reinforcement learning. Now, the reason being, first off, reinforcement learning could be implemented on the user end, on the user device. So basically, it's a form of embedded machine learning algorithm itself. So in that way, the user's data is private to the user, but at the same time, the reinforcement learning agent is capable of like choosing the correct frequency to optimize the performance and power consumption of such smartphone devices. But as you can recall that I have mentioned, reinforcement learning agents are based on actions and reward that it takes. And the reward, the foundation of the reward function itself is based on mathematical formula. And since most of you are engineers or researchers, you know how much we love to like convert anything to mathematical representation. Now, I don't know whether you have watched the TED Talk on the mathematics of love, where engineers have also like represented love in a mathematical representation or mathematical formula. So that goes on to say that how much we researchers and engineers love to convert or translate anything in terms of mathematics. So why not be able to translate the performance and power and thermal management of smartphone into mathematics as well? Now, before 2020, a very popular metric that is used among the mobile computing researcher or engineer in order to translate performance of smartphone and the power consumption of the device is called performance per watt, or PPW. However, such a metric does not incorporate or does not take into consideration the thermal behavior of a smartphone itself, which is very important because given how much we use the smartphone in our daily life, it is very important to also cater for thermal behavior of such devices, especially because it has been also found that an increase in 10 to 15 degree centigrade of the temperature of the smartphone devices could actually degrade the overall lifespan of such devices by 2x. So if the such devices, computing devices, operate at a high temperature, then it can adversely affect the total lifespan of such devices. So you buy a smartphone today, and if there is no thermal management, proper thermal management in such system, then you might end up seeing that in 1 to 2 years, you have to change your smartphone again, or you have to buy a new smartphone, which is not desirable, especially if you end up buying premium smartphone like iPhone or like Samsung Galaxy devices, right? They cost a lot. So you want it to last longer. So that's why in our research team, we designed a new metric which we call performance per degree watt, or PPDW in short. So the main focus of this research is to meet the quality of service while optimizing power consumption and peak thermal behavior based on the user's interaction with the application on the smartphone itself. So as I've mentioned, the metric that we designed in order to incorporate performance, power consumption, and temperature behavior of the device, we came up with the metric we call performance per degree watt, or PPDW in short. Now, the mathematical representation is shown here. So PPDW is actually equal to FPS divided by the difference in the thermal behavior multiplied by the power consumption. Now here, the difference in the thermal behavior is actually the temperature of the processing element subtract or minus the ambient temperature or the temperature of the environment itself. So TI, PI, and FPSI here in the equation are the temperature, power consumption, and FPS at that time period, respectively. Now, the main objective is to minimize the value of this metric, PPDW, while the optimal minimum value, which is PPDW desired, is like achieved by the reinforcement learning agent. Now, another observation that I would like to point out. So after we have designed this metric, we tried to see how on the Samsung Galaxy device, depending on different FPS and its power consumption, how the value of PPDW can change. Now, here in the graph, you can see it kind of increases at certain point and then decreases after a certain point. Now, our goal is to stay somewhere around this region. The reason being, our human eye, when it comes to FPS or frames per second noticing, so when it comes to 60, like between 60 FPS and 50 FPS, or even 40 FPS and 60 FPS, it is very difficult for our human eye to notice the changes in those FPS. But we can definitely change a significant difference if the mobile runs at 30 FPS or at 60 FPS. So our goal is to actually stick somewhere in between so that you achieve a high enough FPS to cater for the quality of service for the app. But at the same time, because we are running the app on a lower FPS, which also means we are capable of running the app at a lower operating frequency of the processor, and thus reducing or optimizing the power consumption itself. So we call our the desired goal is as PPDW desired, which is the value of the PPDW metric, which falls somewhere in between the PPDW worst, where it performs the worst, and the PPDW best, where it performs the best. So PPDW desired will be a value somewhere between these two values. And again, the general trend uh, in on this that I have shown is actually a trend of PPDW noticed while executing a gaming application called Lineage 2 on the Samsung Note 9 device. So now that we have explored or seen the metric that forms the foundation of the reward function of our reinforcement learning agent, let's introduce our reinforcement learning methodology, which we call as next. So here itself, the reinforcement learning agent is an agent that continuously runs and monitors the frame rate every 25 milliseconds for a window of n seconds. So in this diagram, this is a representative diagram of the next methodology or next reinforcement learning agent, where you can see we have engineering wise, we have created a buffer. So in the buffer, we each place in the buffer represent each second. And if we have chosen, let's say, n second, which could be either 3 or 4 seconds, for that, so each 1 second we see or the mode, mathematical mode of the FPS generated. Now, from there, we actually see from the overall buffer, we see what is the mode or mathematical mode of the FPS generated, and that is chosen as the target FPS that need to be achieved by our next agent. So here is the representative that in the buffer, we are continuously monitoring the FPS of the app, executing app or the running app on the device. And from there, we choose the mode FPS and we send that value to the reinforcement learning agent next. So here, that value, which is shared as the mode FPS to the reinforcement learning agent, that is called the target FPS that needs to be achieved by the RL agent. Now, after it receives the mode FPS or the value of the target FPS, the RL agent are capable of taking 3 different forms of action. Those actions include either to scale up the frequency, which is frequency up, or it can scale down the frequency, which is called as frequency down. Or if the RL agent thinks that nothing need to be changed in the operating frequency of the processor, then that is denoted, or that action is denoted as do nothing. So this RL agent is capable of taking these three distinct action such that it is capable of achieving the target FPS as mentioned. Now, once the RL agents start to take this action, it keeps a record in the form, as we call it, Q table, where it keeps record of the different action and the different state, which is the technically the value of PPDW metric, to find out whether the target FPS is achieved or not. And once this record has been appropriately explored, so the RL agent is now capable of understanding, okay, for this action, I'm getting this reward, which is basically like to achieve the target FPS as needed. And after it has explored all these set of action, then it actually choose the maximum frequency of the processor as the desired frequency itself. Now, as I have mentioned, these actions by the RL agent are based on a reward function. So the reward function can actually mathematically be represented in this way, where the reward, which is a function of SI and AI, which is where the S is the state of the agent and AI is the action taken by the agent. So the reward function can be shown equivalent to the PPDW metric value. So the agent's goal is to maximize the reward, which means that the agent has to optimize PPDW and achieve the current FPS, which is equivalent to the target FPS. And it chooses the operating frequency accordingly. Now that we have explored our methodology, let's explore like when we actually implemented it in real device, which was our Samsung Note 9 smartphone or phablet. Let's look at the different performance and power consumption that we have gained. So we have chosen applications such as Facebook app, Lineage, PUBG, Spotify, web browser, and YouTube to compare the power consumption. So keep in mind here, the power performance is the same for all these applications, which is chosen by the RL agent itself. But depending on the application and our methodology, if we compare with other methodology, our application has been able to reduce the power consumption by almost 50%. Now, in Android, the default power and thermal management scheme is called SCHED-UTIL. So we compared our methodology, which is next, with the SCHED-UTIL governor scheme, or like power and thermal management scheme in Android, and also another state of the art, which is the QoS power management system. It was designed for gaming application, but our methodology is application agnostic. So it can run for gaming applications such as Lineage and PUBG, or other applications such as social media and web browsers as well. So Facebook, YouTube, which is media consumption app. So we tested on all of such app, and our next reinforcement learning agent was able to outperform all the existing methodology by a lot of number. So as you can see, we are capable, like using this method, we are capable of reducing power consumption by almost 50% depending on the application which is being executed. Now, this is the same experiment we ran, but this time we observed the thermal behavior or the peak temperature of the processor utilizing our next reinforcement learning agent compared to other power and thermal management schemes such as KGUtil and the QoS power management system as well. So as you can see, our next reinforcement learning agent is capable of reducing the peak temperature by almost 30%, like close to 29.16%. So which is again close to 30%. So we are capable of reducing the peak temperature of the processor of such devices using this form of reinforcement learning agent, where we take into consideration how the user is interacting with the smartphone device itself. So a part of this algorithm that I have mentioned, which is designed by our team, is already live in billions of Samsung devices. So if you are using a Samsung device, you are actually using one of our reinforcement learning algorithm that optimizes the performance and battery of the smartphone device. Now, from this, we are able to see that machine learning is completely capable of understanding our human behavior with computing machines like smartphone and optimize its performance, power consumption, and thermal behavior. Now, understanding such pattern using machine learning algorithm could actually greatly benefit how such a device could be charged, or the battery performance and performance of such device could be optimized. Now, currently, my team is like they have already developed a mechanism to also understand how we as smartphone user charge our smartphone, and using that pattern, the machine learning is capable of prolonging the battery of the smartphone without the need to constantly charge that device. Now, that being said, please keep this in mind. We just recently published this methodology in ACM transaction, which was published literally this month only. And we have to go a long way in order to test the methodology in different smartphones. But I'm hopeful that this methodology, like in coming next like 5 to 10 years, it will be very different and will be far more evolved and can be used in all smartphones where we might not even need to charge our phone that often. Now, another thing I would like to mention, that although at the moment AI or machine learning is capable of achieving a lot of things, but comparatively, AI and machine learning is still in its infancy stage. And like there's a lot more to be achieved in the next 10 years that we are about to see in near future. So this is an exciting field for all of us to work and even explore. So only the future holds what is about to come. Now, that being said, that now you know that what machine learning is capable of doing in smartphone, I would urge you to participate in another poll where I am interested to learn that if you are hopeful that in future you rarely need to charge your phone every couple of days or not. So the poll should be available very soon on your screen. So let's give 30 seconds and we will see what's your opinion after that you have learned that this is already live and a possibility for smartphone to optimize their performance and power consumption and thermal behavior. So let's take 10 more seconds and we will see the outcome.
Okay, Somdip, I will end the poll.
Yes, thank you so much, Kevin.
Okay,
Really appreciate the help.
so I end the poll and I will share the results.
So almost 84% of you are hopeful that in future you do not even need to charge your phone every couple of days. And I also hope that that is the case. But right now, if you are using smart devices, especially I can speak for Samsung, you would notice that comparatively all the Android devices that are available, Samsung's battery performance is outperforming. Not because me and my team have worked at the company and we have developed it, but it's because it is using a machine learning algorithm to optimize its performance and power consumption and thermal behavior. But it's only we are like barely like scratching the surface, as this is still a very new field, and only the future will tell us where we can reach. So that being said, thank you once again for allowing me to present my work and share what we have been up to. If you have any question, you can ask me now, or if you want to get in touch and collaborate, or even have query and want to get that answered, then you can also reach me at my email address as well. So Kevin, should we take some questions now?
Yes, Somdip, thank you very much for a fascinating presentation. It certainly opened my eyes, and I very much appreciate the complexity that's going on behind the screen to optimize our battery life on our smartphones. And I'm sure there will be lots of questions. So folks, if you'd like to, if you've got a question, please use the Q&A panel in Zoom and input your question. My colleague George will be picking up the questions and asking those questions to Somdip. So please think of your questions, and I would like maybe just to kick off with the first question, Somdip, chairman's prerogative, I guess. Just thinking about the technology that you've described, do you think there are applications for this innovation in electric vehicles, the way electric vehicles battery life might be prolonged or battery life might be optimized? Perhaps you could give us your views on the applications outside the smartphone.
Absolutely. Thank you so much, Kevin, for this question. A really interesting one, though. So me and my team also work in how to use computer vision in intelligent traffic transport system. So we use reinforcement. One of the best thing about reinforcement learning, when you compare with other type of machine learning algorithm, is that reinforcement learning agent is capable of understanding its environment that is based on, and then takes the action based on a reward it gets. So if we can give it the correct reward function that it needs to achieve, it is capable of achieving or taking the correct or appropriate action to achieve those rewards. That's why a lot of scientists and engineers also believe that reinforcement learning forms the foundation in achieving artificial general intelligence, which is the goal in the AI field. So general intelligence is the state of AI where AI becomes so sophisticated and smart that it is capable of doing any task as its human counterpart. So basically, we can say like a robot which is capable of doing any task that we human are capable of doing. But the beauty of RL, or reinforcement learning, is that it is one of the first steps to achieving such form of AI. Now, when it comes to, let's say, self-driving car, this mechanism can definitely be used to even prolong the battery life of the car itself, especially when it self-drives. So you already have might have a predefined path that it is taking based on how it is viewing the road environment, right? Based on that, it can actually see whether the car needs to be at a certain speed or not. And that could be like performed by the RL agent itself. Now, me and my team, we have not worked in that particular area. I'm sure if Elon watches this, he and his team might be like taking inspiration or can use the same methodology to even optimize the battery performance and the performance of self-driving car itself. So Elon, if you're watching, you're like free to contact us.
Thank you, Somdit. That's a great answer. So I'd like to hand over to my colleague George Williamson, who will manage the Q&A session. So George, over to you.
Thank you so much, Kevin.
First off, make a plea to the remaining participants in the webinar. Please raise some questions via the Q&A panel at the bottom of your screen. So the first question I have is from anonymous attendee. It says, when some phones switch over to so-called ultra stamina mode, is DVFS in use, thus limiting the running of some apps?
Yes, actually a combination of DVFS, DPM, which is dynamic power management. I've also mentioned about that mechanism as well. A combination of these two is used alongside. So when you switch to like energy efficient mode, usually what happens, the system checks for any like ideal application that is running, because your phone, if you say, if you are using smartphone like iOS or Android, you might notice that you have a lot of applications that are running in the background. So when you switch to power saving mode, it actually checks which of those applications are running on the foreground, which is like the active application, and which are not running on the foreground or which are running on the background. So the ones that are running on the background do not need to utilize any of the processor. So you can see here a combination of task management, along with the processor is also happening. So in power saving mode, most of the time it checks for, okay, which application are running in the background. Those applications are put in ideal mode. So no processor is allocated to them. Moreover, actually DVFS is also applied such that like it automatically puts the processor's frequency at a lower frequency, so that you can end up prolonging the battery itself. But again, keep in mind the power saving mode actually has performance degradation, because when you are in power saving mode, if you are running gaming application or let's say media application, you might see the differences if you are not running like the power saving mode itself, because the power saving mode automatically by default forces the processor to run at a lower frequency without thinking about the performance requirement of the executing application. Now, that being said, comparatively, our next methodology is different. It actually chooses the operating frequency of the processor depending on the performance requirement and as well as which one takes the least power consumption. So I hope that makes sense.
Thank you, Somdip. I have a question from Graham C, which is related to Kevin's initial one. So I'm going to develop it a little bit, if you forgive me on that one. He asks, what are the possibilities of using this thinking in applications for heavier duty applications, for example, electric automobiles? And it strikes me within that context, there will be certain applications for the electric vehicle which are safety critical. And how might your methodology be enhanced to deal with those safety critical aspects? And indeed, one of the oft noted attributes of machine learning is it's sometimes difficult to get an adequate explanation of the reason why a decision has been taken. And it strikes me in those safety critical areas, in order to validate the correct operation of these, that explanations will be required. So how might your approach be enhanced to deal with safety and explanation?
Amazing. Thank you so much, George, for this question. And I really appreciate it. Although I do not want to give an information which might not be valid, because I personally have not implemented or worked on like developing or extending reinforcement learning agent in safety critical systems, especially where decision has to be made in nanosecond or even in millisecond, because of the like requirement of such a system. But that being said, I know that actually there's an extension or like or alternative form or expansion of reinforcement learning mechanism that could be used in real-time system. And that is called deep reinforcement learning, where you actually use neural network along with reinforcement learning to speed up the inference process and also the learning process itself. One thing you have noticed that today, the reinforcement learning agent that I have shared, that is specifically is a Q learning based reinforcement learning, which is like it has a Q table, which has the set of action and state of the environment. Now, if the number of actions or the state increases in such an environment, then the exploration for such reinforcement learning also increases. So the exploration time also increases. But you use a combination of deep learning or like neural networks along with such like Q learning system, then it can reduce the exploration time, which could lead to almost real-time decision making. So deep reinforcement learning could definitely be used in real-time system. But again, personally, I have not worked in safety critical system itself. So it would be unfair on my part to like provide any specific answer on that. I hope like that answers the question.
Thank you. Question from Graham Panton, who says, with the escalating cost of energy, is there potential for reinforcement learning in the management of home heating?
Yes, absolutely. Actually, me and my team are also like working with a company who does like how to use not just home. So in smart cities, you can actually regulate your heater using like a computing processing system, which also manages other smart home devices, right? So we are working with such smart city project to use reinforcement learning to optimize the energy like consumption which is generated through heating systems as well. So we do have project in that area. And those projects are actually KTP project or knowledge transfer partnership project that we work with the industry.
Okay, and a question from Kane. Do you see this could be applied in load management in microgrid?
I have not worked in that area, so unfortunately, I do not have much idea in that regard. So I'm so sorry, but I can explore a bit about the topic and might be able to give a better answer. My focus is mostly related to embedded systems itself and achieving net zero carbon emissions in future through embedded, like optimizing power consumption and performance in such devices. Because in next like 5 years, everybody, or like it is speculated that everybody on the planet will have a smartphone, and it will become the main mode of personal computing device in our lives. So our research is mostly focused on that. apart from that, we actually also use reinforcement learning in food supply chain to reduce food waste as well. And our team is also the first team in the world to design blockchain-based machine learning algorithm, which is like based on reinforcement learning to reduce waste in the food supply chain. So that's where my expertise like mostly falls. So unfortunately, I'm not completely sure about the microgrid system.
Okay, we have no further open questions. Can I ask you one question, which is, can you speculate about the amount of energy that you may already have saved through the devices that you have been managing more efficiently?
So in terms of carbon consumption, or I can say, let's say, uh, the billions of Samsung devices that is running our machine learning algorithm is capable actually of like saving 5 to 10% in general, compared to if it didn't have such a mechanism on the devices, smartphone devices. So billions of devices running, which is saving almost 5 to 10%, depending on which application it is using. So 5 to 10% is still a lot, which is like billion, or especially given it's running on billions of devices. So I'm really proud of what me and my team has achieved in this area, because again, we only have one planet, and I believe that we, especially for our future generation, we need to leave it at a state where they can enjoy the beauty that we have enjoyed when we are young, like we were younger, or we are now. Now, global warming is a very important issue. I know there are conspiracy theories, some do not still believe it, but I can tell you it is real. And us engineers here, we know it is real. So when it comes to like reducing global warming, our goal, which is net, like achieving the net zero carbon emission, is very important so that we can at least maintain the status quo that we currently have when it comes to carbon emission itself. And our work is so significant because, well, like after iOS, like Samsung has one of the largest like market share when it comes to smartphone devices. So we are extremely proud of what me and my team has achieved or will achieve in future in this area.
Okay, thank you very much for that. I've just looked at a stat on Google. It says Samsung have reported to governments that they had consumed approximately 255,000 terajoules of energy since 2011. So 10% of that is a lot of energy. Something worth going for. Thank you very much. I think I'd like to pass this back to Kevin to make some closing statements.
Okay, many thanks, George and Somdip. Thanks for a great presentation, Somdip. You covered a lot of ground there, some very interesting, innovative kind of research with really excellent practical application. So my thanks for you pulling the slides together and presenting tonight. Very interesting. My thanks also to George for grouping the questions and asking the questions on behalf of the audience. Folks, I'd like to remind you all that we are recording the webinar and it will be made available on our IET Eng site. It'll take 2 or 3 weeks for us to get the video up because we do have to do some processing, a little bit of editing and make it available, but we will make it available. The CPD certificates will be made available as well on the IET Eng website. Now, I just would like to share my screen.
Thank you so much, Kevin, and thank you everyone for like being patient with me and like allowing me to share my work. Thank you.
So I just want to oops. Sorry about the audio there. Before we close, I just really wanted to plug our future Anglian Coastal Local Network webinars. We've got one coming up on the 21st of April. That's on dark energy by Dr. Ed Friedman. If you saw Ed's presentation on black holes and you like that, I'm sure you will really like his presentation on dark energy. So that's on the 21st of April, Ed Friedman. So look out for that one. So if you would like details of that and any of the other webinars, recordings and future webinars, there's the link on the slide there. And as I mentioned before, CPD certificates and videos for today's presentation will be posted on this site. Finally, Somdip, thank you so much for tonight, for answering all the questions and the presentation. And on behalf of the IET Angling Coastal Local Network, thank you all for joining tonight. And thank you to the team who put on tonight's webinar. That concludes the webinar, and you may disconnect now. Thank you.
Thank you, everyone, and have a great evening ahead.